Hello everyone. I am Khushbu, a PhD student at University of Pittsburgh. Thank you for tuning in to my presentation. Today I am going to present our work on remedial reading recommendations using student knowledge state. This work was done along with my collaborators Lei Zhang, Dr. Daching He, and Dr. Peter Brislowski. Let's dig into some background. We are looking at intelligent textbooks. Intelligent textbooks provide students with online learning platform where textbook is divided into chapters or modules. Each module consists of n number of reading sections followed by an assessment. Assessment help to estimate student learning and provide self-reflection. In scenarios when student fails on an assessment, student knowledge deficit on particular concepts is exposed. This is where remedial recommendations come into play and help in completing this learning loop. To provide remedial readings on a failed question, mapping is required between question and section that can help with remediation. This mapping is readily available with classic computer-assisted instructions, where both readings and assessment are created by a team of experts. However, modern online learnings extensively uses open educational resources and question banks, so no such mappings are available. A natural way to address this question is by using text similarity for recommendation. For recommending similar sections to questions. Few challenges with text similarity are: first, recommending advanced content where students might lack prerequisite, or recommending redundant content where students already have mastered those things. And again, none of these are personalized to student need. So, goal of this work is to provide student with relevant remedial recommendations tailored to students' need. To approach this, we would like to explore the possibility of using concepts as a way to bridge the gap between questions and sections. Our definition of concepts are key phrases which are explained in reading sections and are tested on quiz questions. As shown in the question, all the underlined words are mentioned concepts, but the ones with the green lines are being the concepts tested in this question. Further, if we also have students' knowledge level on each of these concepts, it can further help us to find adaptive recommendation. Motivated by this, we try to explore three main research questions in this work. First, is there a benefit to use concept-based recommendation over text-based recommendation? Second, does remedial recommendation benefit from knowing students' dynamic knowledge state? And third, can we utilize automated key phrase extraction techniques for associating concepts with sections and questions? This is in particularly important when expert-based concepts are not available. To study these research questions, we utilized one of the online textbook platform, Reading Circle. The screenshot shows is from information retrieval class, which provides students with class readings. Each section in the textbook is associated with expert concepts. All student interactions are logged by the system. At the end of each chapter, students are given quiz, where again, each quiz is associated with expert concepts. The idea is to provide remedial recommendation once students fail on a quiz. To check if the recommendation is correct or incorrect, we need a ground truth, and also for our own experimentation purpose. An ideal case is to ask student for feedback or test their learning rate. But as we do not have this already implemented in our system, we decided to generate expert-based ground truth where each question is mapped to relevant remedial section. The assumption is expert will be able to map the relevant recommendation helpful to most of the students. Now, we used expert-based annotation to generate concept-based recommendation. As shown in the figure, in the slide, we represented both books and sections as binary vectors, depicting their association with concepts. Once the student failed on a particular question, we matched the vector associated with the question to all the sections in the textbook and generated a ranked list of top n sections based on cosine similarity between question and book sections. This will give importance to those sections which explain most of the questions associated with the failed question. To evaluate the results, we used mean average precision of top 5 ranked recommendation, and secondly, mean reciprocal rank over recommendation rank list. As the text-based similarity is our baseline approach, which already reached MAP score of 74 and MRR of 0.83. We found that concept-based recommendation alone are not able to pull the relevant documents as the performance of only concept decreases. So in our third experiment, we combined both text and concept based and found a significant boost in the result, as can be shown in the table. This shows that concept representation when text combined with text-based recommendation provide better recommendation, which agrees more than 80% of time with the expert-based remedial recommendation. Now, our next step is to integrate knowledge in our recommendation to get students personalized recommendation. To generate student dynamic knowledge state, we introduced a student model in our textbook flow. The student model is based on students' assessment interactions, which are logged by the textbook. We used classic performance factor analysis model to infer student knowledge. The model was trained on student interaction logs, and expert-based concepts were used as knowledge components for training PFA. Once student failed on a concept, we generated student knowledge vector by inferring probability of students' failure on each concept using students' historic data. The hypothesis is the more the probability of failure, more importance should be given to those concepts. Now, when we have student concept vector as well as student's knowledge vector, when a student failed on a particular concept, we used questions concept representation and students current knowledge based vector and performed a dot product between them to generate failed questions representation. Then we followed the same cosine similarity based ranking model. Let's see the results obtained after this. The previous two results are already seen the previous two results. Just like concept and concept representation, knowledge-based representation also performed better than text-based similarity recommendation. One reason, however, there is a decrease in the result found between concept versus knowledge-based recommendation. One reason could be the disagreement between expert-based section mapping and student knowledge. So let's see how knowledge-based recommendations are different. One important aspect of knowledge-based recommendation is they should provide different recommendations to different students. So to check this, we plotted this graph where x-axis is the number of unique recommendations and y-axis is the frequency of quizzes with those unique recommendations. We noticed that more than 86% of quizzes had different recommendations for different students. In fact, there were cases where failure on a particular quiz is mapped to 15 unique sections for different students. This shows that student knowledge does provide personalized recommendation. Next question is, which recommendations are better? To understand this, for each question, we divided the sections into three parts: previous sections, current sections, future sections. Current sections are sections which students are learning or which students are performing this quiz. Previous sections are the sections which are either prerequisite sections or are being already mastered by the student. And future sections are the sections which are advanced or irrelevant sections. Now, we plotted the number of recommendations in each sections by different algorithm: text, concept, knowledge-based algorithms. As can be seen, 50% of time, text-based recommendation recommended irrelevant recommend sections, which shows that the bad quality of text-based recommendation. While both concept and knowledge-based recommendation most of the times recommended current sections, which student is performing quiz for. Also, we saw that there are times where knowledge-based recommendation recommended more previous sections than concept based recommendation. This could be the time where student is still lagging on prerequisites and performing an advanced question quiz. This shows that student knowledge provides personalized recommendation, and the recommendation quality is better. Now, to address our third research question, which is, can automated concept extraction be used for recommendation? We selected three well-known key phrase extraction techniques: text rank, copy RNN, and topic rank. Given time limitation, I will skip the details of it. But the result we concluded was all the automated concept extraction did better than text similarity. In fact, few of them surpassed expert-based concept extraction. This shows that it is possible to augment these recommendations where concepts are not readily available. So, in conclusion, we found that concept based recommendations help, but yes, when augmented with or existing text based recommendation. Second, augmenting dynamic knowledge state provides better personalized recommendation. In future, we would like to understand have a more comprehensive evaluation with students in the loop of recommendation through either student feedback or understanding their learning gain. Second, we will also like to use this method to recommend open source learning resources like Wikipedia or blogs. Here I complete my presentation. On the left side is my other team members. The dataset and code details are given below. I would be, if you have any further questions after this conference, you can contact k.thakur@pit.edu. Thank you so much for listening to my talk. I look forward for questions and suggestions. Thank you.